The petroleum industry operates with a severe physical constraint. Its most valuable assets are buried miles underground in total darkness, completely inaccessible to human sight. To navigate this darkness, operators collect an immense amount of data. We record 3D seismic echoes, pull up physical rock cores, and stream raw telemetry from probes. The problem is that all of this information arrives entirely disconnected. Analyzing a single spreadsheet of pressure readings or an isolated rock sample is mathematically insufficient. You cannot understand the complex behavior of a massive, continuous underground ecosystem by staring at floating fragments of data. The solution to this fragmentation is a process called reservoir modeling. OmniPetro uses this process to act as a bridge, pulling every scattered piece of data into a single, unified digital replica of the subsurface. To safely extract resources, we have to bypass the limits of human perception. By engineering a complete virtual environment that precisely mirrors the Earth, we can finally see what we are doing. Building this environment starts with physical integration. The system takes those disparate streams, the seismic lines, the well logs, and the rock physics, and merges them to establish the exact three-dimensional outer boundary of the reservoir. OmniPetro fractures the volume into geological grids, dividing the environment into millions of distinct digital cells. Each cell logs the exact rock type, porosity, and permeability. Locked together, they form the static model, the permanent structural skeleton mapping rock layers and deep geological fault lines. But a static model is exactly that, static. It maps the massive architecture of the deep perfectly, but it fails to account for the fact that the earth beneath our feet is moving. Subsurface reservoirs are not dead, empty rocks. They are highly pressurized, volatile environments where deep water, oil, and gas are in constant, forceful motion. To capture this motion, OmniPetro introduces dynamic models. By layering the rigid grid with the laws of fluid physics, the system transforms the static map into a reactive engine capable of simulating exact fluid migration. This adds the element of time. As artificial extraction begins, these dynamic models continuously calculate how pressure drops in one cell will force complex fluid reactions in the thousands of cells around it. With this temporal dimension added, engineers track invisible physics as they play out in real time. Even with physical laws applied, deep geology involves the unknown. Absolute certainty is impossible, meaning operators must constantly navigate complex probabilities and hidden structural risks. OmniPetro handles the unknown through Reservoir Simulation, splitting the dynamic model into dozens of parallel realities to test different well placements. Artificial intelligence runs thousands of microsimulations, producing visual heat maps that highlight optimal extraction paths in cool colors and hidden risks in bright orange. By simulating the future across thousands of variables, engineers can identify catastrophic risks and perfect their strategy before spending a single dollar to deploy a physical drill. OmniPetro remains an active, evolving entity long after the planning phase is over. The moment a physical drill cuts into the earth, a live data loop begins. Constant telemetry, drilling variables, and daily production feedback are beamed straight from the physical wellhead back into the software. This flowchart demonstrates the system's immediate reaction. The model processes the live feedback, instantly recalibrates its geometric grid, updates its internal pressure readings, and refines its future predictions based on reality. Yet, despite the immense computational power of the AI, human experts remain at the center. Geologists and reservoir engineers review the updated scenarios, interpret the AI's complex findings, and make the final strategic decisions. This continuous symbiotic loop between live field data, artificial intelligence, and human expertise creates a living digital twin. OmniPetro transforms the subsurface from a dark, unpredictable void into an intelligent, living simulation. It allows operators to master the future, testing every operational decision before it ever happens in the real world.